You're like, I don't know, I spent 2 hours last night at home just picking up distance learning stuff and looking at their work and dealing with it. And that was after doing it for an hour after school, so I had 3 hours yesterday that I put into distance learners. More than I put in for you guys, creating your test intake that long. So, it's not easy. But what is? So, matrix addition. You can take a matrix and you can add it to another one, only if the matrices have the same dimensions. Otherwise, you think about it, you had a matrix that was a 2 by 2 and one that's a 3 by 3, what gets added together? Which components of the matrices would be added together? It's not going to be defined. So they give a definition of matrix addition right from the get-go. And they say that two matrices A and B have the same dimensions, then their sum would be A plus B. And every element, or every part of the matrix in one is going to correspond to that of the second matrix. So like row 3 in column 4 has to be added to row 3, column 4. And I mean, it's obvious right now. But we're going to be doing some things later on with matrices where we take the matrix and we actually rotate the numbers in order to do matrix operations. So keep what makes sense here in the back of your mind. So they've got, they talk about how that would be used. And they have a car dealership that has a current inventory of, what do they have? They have 4 different cars that are in 5 different colors. I'm trying to remember if that's like the interior or that's the outside. Maybe it's the outside color. But then they're taking delivery on more of those same cars in colors. And what they simply do is add how many they have to what they're taking as delivery, and that's their total number. Well, why understand this? Well, it has to do with how we lay out spreadsheets in business for keeping track of inventories. So that's kind of the foundation of all of this. So if you had 2 matrices, you can actually make them add together on your graphing calculator. So what do you guys have stored in there right now? I have a 3 by 4, a 3 by 2, and a 2 by 2. Do you still have that much, or I don't know what you have? Do you know how to clear them all at one time? Because otherwise they're tedious to clear. I think if you go to second memory, and then you go down to number 2, memory management and delete. Yeah, but then you're dumping everything. But you don't want to do that because there's other settings you might have the same. So second memory, which is the plus, and then you scroll down to number 2, which is memory management / delete, and then you go down to matrix, and what you do is I think you use the delete key, if I recall correctly. So when the arrow is pointing at a matrix, you just hit delete and it's gone. It's cleared, and then you would have to reset it up with the rows and columns and everything when you do entries in it. So let me show you something here. Go back to second memory, which is the plus key. And then number 2, memory management. And then go down to matrix. And then they all show up. And then the delete key, which is top center above the stat key. So you go above the stat key, then you just hit that delete, and it clears them one at a time. You can also use your arrows to move down to one of your matrices to delete it selectively. So are you good? Are we good over here? Are we good now? Yeah? Okay.
My calculator said that they were still there, but they're gone. And then they went back into memory and now they're gone. So I don't know what happened.
I don't know either. Well, they're gone, that's what we want. So go back in, let's just do a real simple, set up matrix A as a 2 by 2. And just put numbers like 1, 2, 3, 4 in there, just something real simple. So you gotta go over to edit, right? And do a 2 by 2, and just 1, 2, 3, 4. So that you have this. Then go back to matrix and go to set up matrix B and make it also a 2 by 2. And maybe make it 5 for lack of creativity, 6 and 7. 5, 6, 7, 8. So now you have two matrices. So I do this when I write matrices. I don't make the cute little corners on there. Because this is a little bit quicker. So, you know, if I was taking my time, I would do this. But I just put bars like that. I hope you can live with that. Everyone has so far. Okay, so what we gotta do is we gotta take A, we have to add it to B. So what it would get would be like the 1 and the 5 would come together, the 2 and the 6 would come together, 3 and 7 and 4 and 8. Yes? Does that make sense? Okay, so what I'd like you to do is, once you have A and B entered, do second mode, which is the quit, takes you back to the regular screen. And what we're going to do is we're going to work on the regular screen, and we are going to put in A plus B, and then you'll get to see how this looks. So now, when you're on your regular screen, go to second matrix, and then you're going to have the first matrix highlighted, and it should say 2 by 2 next to it. Hit enter, and then plus, and go back to second matrix, scroll down and highlight B, hit enter, and then on your screen it will say A plus B. It'll be like this right up here, it'll be A plus B. And then when you hit enter, it'll flash matrix up onto your screen.
May I have your
Okay, so you know what we're doing, right?
lockdown drill. We are in a lockdown drill.
So just take your stuff, set it on a chair.
Thank you. The drill is complete. Good job, students and staff.
You gotta watch all that.
Or I would actually try to get at fabula, you know, or not that way.
So now I'm just telling them, go, so just watch that and see it.
I used to work with a really emoting type of teacher who was, at one time she was teaching down in the Denver area. And she was talking about a lockdown that they had that went for over 6 hours. She said like 8 o'clock at night by the time they got out. Kids were pissing in buckets and everything, it was horrible. And she was talking like that, but for real. They're in a room, 6 hours, weren't going anywhere. Lockdown.
Was it a real one?
It was for real, it was real. It wasn't a drill, no, it's just real. The real McCoy. Yeah, gang activity, guns in the building. And they couldn't, it was big school, and they couldn't separate out. Yeah, Colorado was really intense. In part because of Columbine, because that was probably the first significant one in a school. And, I mean, we had backpacks and everything that were full of food and things to make it for a long time with a big class of kids. It was way different. And we had them. It was no fun. No fun at all. Okay, so, where did we end up with? Did we get this thing, did you get it added and see what it turned out to look like? I added mine, I don't know if yours went that far or not. Yes? So what did you get it to look like a matrix like this? Yeah, you did a whole bunch of that. Yeah, and actually, you know, if you needed to use that matrix later on, what you can do is you can, before you do the, you know, the A plus B thing, what you can do is you can store your matrix. Before you do the calculation, you set up a store function so that when you calculate the new matrix, it automatically stores it as like matrix C or whatever you want it to be. And when we get into more complicated stuff, I'll teach you how to do that. So that's addition, real simple, real straightforward. The one that they get into a little bit more with this lesson is called scalar multiplication. So scalars are numbers that we use to change the scale or multiply. So you could take, for example, matrix A, and you could double all of the numbers by multiplying all of them by 2. And if we were going to write the notation for that, we would just put a 2 in front of our matrix, write it like this, and then you can say what it is. Well, that 2, it's kind of like it gets distributed in a way, so it'd be like 2 times 1, and 2 times 2, and 2 times 3, and 2 times 8. And we can do scalars of matrices on the calculator as well. So if you wanted to just take matrix 2 and, I'm sorry, matrix A and multiply it by 2, just on your regular screen you would say 2 and then times, and then go to your matrices, the list. And so you got 2 times, and then you just hit enter and you pull up the matrix you want, and then it's going to read 2 star A, and you just hit enter, and then it whips out the new matrix for you. So these things work very nicely to get a lot of calculations done very quickly. Now, in the activity here, they end up having you work a matrix that has variables in it, like A, B's, for example, A, B, C, D. And you can enter those in, and you can multiply them out, and then, you know, like if these instead were A, B, C, and D, well then when you multiply 2 times that, you would have, you know, 2A, and then you're gonna have 2 times B, and 2 times C, and 2 times D. So that's what that activity is doing for you. It's just showing that you can do it algebraically, but I'm showing you that you can actually do it with real numbers. So I'm not gonna take time to go over that. I'd rather have you do some work. The scalar product is the result of scalar multiplication. So this is the product, scalar product. They give that a definition in the book. So it says the scalar product of a real number k and a matrix A is the matrix Ka in which element k times the corresponding element in A. So what they mean by that is, if this is k, your scalar, and this is matrix A, the result is going to be k times that matrix. Every element is going to be multiplied by k. So it's fairly obvious. Example 1 just uses different numbers than what we did here, so we don't even have to do that. If we understand this concept, we can run with it. We can do matrix subtraction as well. And that's the last part of this here. So no different than addition, it's just that we're going to subtract them. Excuse me, you end up having to have the same dimensions of the matrix in order to subtract. Of course, you have to have an element per element when you're doing the subtraction. And the example that they give is a word problem talking about the number of males and females in different professions: medicine, dentistry, law, and theology. What's theology? Something, yeah. Religion, yeah. Medicine, dentistry, law, and religion, religious studies. And they're talking about the number of males and females earning degrees in those things in 2 different years. And in order to find the difference or the change from one year to the next, you would subtract the matrices. So, you know, that example is showing how we can use matrix subtraction to come up with changes that occur during intervals of time. So rather than go and spend time putting all that information in, if you understand the concept that a difference is a change and it could be done over time, you're good with that. So I think I'm just going to let you work on the homework. You got a little bit of time, and be able to help you clarify anything that is being asked in those questions. Let's see here. 4.2. 1 through 15 on page 231. 1 through 15 on 231.